And thank you all for being here. So I'm going to give you a little background on Niagara. Who here has heard of Niagara before? Great. Were any of you guys at Universal Studios last night? We actually had a Niagara branded vending machine in the park. I saw a couple people walking around with our water. Yeah, that's actually pretty unique because we private label for over 500 different companies. Costco, HEB, for example, Kroger, Sam's, Walmart. So people don't often see our name, but here are some interesting facts about our company. We currently have 34 plants here in the US, two in Mexico, two in the UK, and three in Australia. But that number grows every year. I think we add 2 to 3 plants per year. So we're always expanding. Last year, we sold 1.6 billion cases of water, which was a 16% growth annualized over the last 5 years. So our company is huge and we're growing rapidly. And because of that, the innovation and the convergence of the types of technologies we're here to talk about is really important. That's been our competitive edge. We have the fastest bottling lines in the world. We have 106 lines as of this moment. Ask me again in a few weeks, it'll be a different number. With our maximum speed of 40 bottles per second. So this photo is actually not a time-lapse photo. It's a normal photo with a normal camera. They're just running that fast. And we've also been the industry leaders in lightweighting bottles. We're currently at 7.15 grams per bottle for our 1 liter bottles, or half-liter bottles, I should say. So if it feels like it squishes and turns into a water balloon, that's why. We're taking all of the plastic out of it, which gives us some different challenges in the manufacturing side in processing it. So that's actually why technology innovation is very important to us. We have to find creative solutions to new problems that we create for ourselves. All right, so I'm going to give you an overview of some specific technologies that we have in use at the moment, and a few that we're looking at using in the near future in the different realms. First off, we have our information technology. We use segmented LANs. We also have WANs and VPNs, but the segmented LANs really help us control our traffic flow. We have a lot of data as we make our devices intelligent, as we add more capacity, more sensors, we have a greater throughput. And so these segmented networks are really important to us to guarantee uptime and availability of our data where it needs to be. You know, there's no reason that a data point has to go through a sensor, through a bunch of different networks, and then back to some other machine that was sitting right next to the sensor. So the optimization of these networks is really important to us. The way our firewalls are set up are also really important, making sure that we can communicate between all of the different data sources, and I'll get into that later on in one of my examples. We heavily lean on virtual machines sitting in each of our factories. We have a server stack, and that allows us elasticity. So we can dynamically scale up our virtual machines' compute power and scale them back down when we need to. That's what a lot of people do with cloud technology. We've chosen not to internalize that, or not to use cloud technology, but to internalize a version of that for our personal usage. And we found some great advantages to that I'll get into. We leverage databases, computer workstations, and then also web apps. Some of our vendors have cloud platforms that we use, and reporting tools. I kind of put that in the IT category because IT professionals have been doing that for a long time, even though there's some overlap between that directly with OT. So some of our operational technologies are PLCs, microcontrollers, SCADA systems, MES systems, warehouse management systems, our industrial control networks, which are different than our regular internet networks. Industrial communication protocols are very important to us. We primarily lean on OPC and MQTT. I don't know if you guys have met him. One of the co-inventors of MQTT is here. I saw him yesterday. Really neat guy, but that protocol has actually saved us a lot of money and a lot of headache just with the standardization that is available through it. We also have here our vision systems, which are really important to us. We use those a lot for quality. And then we have dashboards, which kind of is what overlaps with reporting. But these are all existing technologies that traditionally have been siloed in the operational realm. And then, of course, we have the fun new stuff that Paula has cleverly deemed engineering technologies. So you have your virtual reality, your augmented reality, mixed reality, which is like augmented reality on steroids. We have machine learning. I actually put deep learning as a subset of that. So deep learning is unsupervised machine learning, where there's not an explicitly defined goal for the algorithms. It just identifies things of interest for you. We have things like data science platforms. So if you don't have a data scientist in-house, you can buy a data science platform. There's a couple of them that were here in the showcase, and they'll actually take care of the algorithms for you. All you have to do is plug in the data and then figure out how to use the outputs of their models. That's a really interesting new technology that we're exploring. Also, the use of wearables on the factory floor, smartwatches, for example, smart glasses, AR glasses, haptic feedback sensors. There are all kinds of unique new opportunities to interact with your users and interact with your systems. So we're starting to look at how we can leverage those in a productive way. Then you also have your smart sensors that don't necessarily need a PLC or a microcontroller. They have a radio device built into it or a LAN connection built right into it. So the sensor itself is actually communicating with some higher order system. We don't use those a lot, but we're looking at a few applications where we just don't, there's nothing else around, or there's environmental constraints that prevent us from putting a full system in a certain location. We're also starting to use 3D modeling. So that can either be through photogrammetry and image processing, or it can be from CAD drawings and K drawings from our construction companies. And then we're starting to look at using simulations as well to model some of our processes and enhance automation. So now we're going to get into the most interesting part, the specific examples. And I'll preface this with, these are very specific to the manufacturing environment, and specifically the high volume, high speed manufacturing environment. So I tried to convert them into the principles behind why these convergence points are so important, and hopefully showcase the opportunities across other types of industries, not just our specific industry. So we'll just get into that. One of the things we've done, I think it was back in 2015 is when this started, is the automation of changeover events. So if you have a line that has a set of equipment, it might be capable of making several different types of products, right? So depending on how you do your manufacturing and your ordering, you might have a lot of changeover events. In the case of water bottling, and making 500 different labels for those water bottles and different types of beverages to go inside of them, we do a lot of changeover events. So we found one of our key opportunities was the automation of those changeover events. So we actually converge our MES system, which is an OT technology, with our business planning tools, which is traditionally an IT technology. Our IT department manages like our Oracle databases, our order management systems, our customer interfaces. So we found that there was a really good opportunity to merge those two types of systems together and cut out things like overproduction. So, at 40 bottles per minute, if you're running for an extra 10, 15 minutes, that's a lot of excess product. And we don't really have room to store that in our warehouses. So we found that was a huge unexpected benefit from this project. We also found that we could bidirectionally share the data, and that allowed us to have better forecasting for our business planning and our order planning process. So this is a project that was piloted at one location. It was very successful. It's now been implemented at scale across our entire company. And if you have more specific questions, we can get to that later on in the discussion. So another example is multi-system dashboards. We have a lot of different vendors for different types of equipment, our injection molding systems, our resin processing systems, our conveyors, our blow molding equipment, our filling equipment, and then our warehouse automation system. And they each come with their own dashboard, and each vendor wants to sell you their specific metrics. So what we found is there's a really good opportunity to get all that data out of those systems on the back end, merge it together, and present it to users in a useful way. So we're actually presenting different types of data from different types of systems and across different types of vendors for the same equipment, and presenting that to our operators, our plant directors, our QA technicians. So we make the data role specific on our dashboards. That way you see what you are personally interested in, the metrics that affect your job and your role at the company. And then some benefits from this project have been we enabled plant level optimization. So the interactions between those systems, where we have our resin coming in one end of the building, and we injection mold it, and then it goes over to our blow molding station. Those are discrete systems. There's a handoff there that we have created for ourselves. And so we found there's a lot of optimization if we share data across those systems to improve that process and improve our overall process. It also provides context for complex events. Sometimes things go wrong early on, upstream, and you don't necessarily notice them until you're really far downstream. Like a pallet collapses in the warehouse. Literally, that could be any part of the process ahead of that may have caused it. So by bringing all of this data together, we can actually start to reverse engineer what happened in those events and do some advanced diagnostics and correct our process, or in some cases, correct our designs or our metrics that we're using. It also allowed us to standardize the layout and presentation of information, which is really important. So we actually use something called the High Performance HMI Handbook to guide the way that we build our user interfaces and the way that we think about presenting data to users. And that's been something that's just now starting to pick up. That's kind of got tacked on at the very end of this project, but that's something that we're already seeing huge benefit from. People don't have to relearn systems. When we hire new operators, it's intuitive what the data is, where it's useful, what the value ranges should be, and how to take action based on that data. So that's something that we're already seeing value from this project. So this is another project, and this is one that's actually just in initial testing right now. The convergence of AR, augmented reality, with our preventative maintenance care. So we have a lot of multi-million-dollar assets, actually exclusively multi-million-dollar assets in our facilities, and we do regular maintenance on them, either weekly, monthly, or for an annual rebuild. And these are complex processes, and sometimes tasks get missed or they're not done correctly because of poor training. And that causes us a lot of problems with downtime, repairs, non-conforming materials, non-conforming orders. So we've identified that there is likely a good opportunity to use AR first to train the operators and mechanics in these processes, and then secondly, to guide them through the process. It will allow us to increase the consistency of those tasks as they're done, making sure they're done in the same way, measuring metrics that the mechanic might not necessarily have time to make notes on. And then it also provides verification of work. It will allow us to not miss a task accidentally. So we're very excited about this. We're in the initial testing phases using the Microsoft HoloLens and PTC's platform for developing on that. And we expect to see other applications of AR in the near future after this project. Another interesting project that's probably pretty unique for a manufacturing company is the use of natural language processing for our customer interactions. So this is our customer interaction systems for ordering, for feedback, for getting support, which is traditionally an IT system, with natural language processing, which is a form of AI and data science and engineering technology. So we've identified that we can actually extract insights from all of those customer responses, and we can do it automatically to reduce the labor cost. Paula mentioned labor as one of the key costs, and I think that's absolutely true. That's what technology is so valuable at doing, is reducing the repetitive tasks. So we found that we can use natural language processing to extract insights from that and actually improve our performance hitting customer metrics, because we can identify things that are important to specific customers and specifically focus on those things. There's also some indirect cost reduction in eliminating fees for certain types of either late activities or over delivering too much product to their warehouse, things like that. And we found increased performance for other quality metrics as well. So this is implemented at our corporate location. It's not specific to any of our plants, so it's not a mass implementation, but We were already seeing great benefit from this and looking at other applications of natural language processing for other types of text data. This is a project that I'm working on right now, actually, deep integration with our suppliers and partners. So that's something that people talk about a lot, is sharing data, for example, with your equipment manufacturers or with your suppliers, your material suppliers, if you're a mining company, the mines. In our case, we have resin companies that we purchase resin from, labels, stretch wrap for our pallets, spring watered, all kinds of different raw materials. We found that by sharing our data about our current silo levels, for example, or our current consumption rate for the week, the supplier is actually better able to forecast our need and give us a cost reduction in price. So this is a really innovative project that's already saved a lot of money just in the initial testing phase, more than expected. And we plan to continue doing this and adding more suppliers and partners to this. So this has allowed network optimization, not just of our company, but of our strategic partners and suppliers as well. It's reduced their cost, it's reduced our cost, and most importantly, it guarantees material availability, which is really important. Sometimes, due to the 40 bottles per second, we run out of materials. Not very often, but it's really bad when that does happen. We have a lot of wasted time and wasted assets, and I don't have to explain how bad that is to you guys. And this is perhaps one of our most interesting projects. So the convergence of operational and quality data and machine learning. And specifically in this project, we are trying to predict, my apologies. Perfect. Much better. Too much singing with karaoke last night. Anyways, so predicting measures or predicting values for variables that we can't actually measure. So this is things like our quality checks that we do manually every hour, or just things that are inside of a process that we literally just can't measure, or at least not measure in real time. We are gathering data sets of those manual measurements and pairing them with the operational and the other quality data that we have from our equipment. And we're throwing that into a machine learning model to actually predict those values. So what that's going to do for us is allow us to have a continuous metric for that value that would have otherwise been measured once a day, once a shift, once an hour. And that allows us to have hyper optimization of that process. It gives us better understanding of that process. In some cases, even our R&D department or material science team doesn't exactly know how it works. So we're getting insights for that process. And then we have enhanced quality metrics. We've actually found that in one particular case of this project, we were not measuring the correct quality metric. And it was actually causing us to waste a lot of material, waste energy, and processing time. And so we actually changed our quality metric, which changed how the process works, how the feedback works, and we've saved a lot of money from that and actually have better products because we're measuring the correct metric. So these are just some of the examples that are unique to our situation. We have a lot of other projects going on. But thank you for listening, and I would love to answer your questions later on in the panel discussion. And now I will hand it off to Gustavo.